Hello viewers, the liquid and plastic limits of soil depend on amount and type of clay in a soil and form the basis for soil classification system. The liquid limit of a soil is the minimum water content at which the soil is still in liquid state, but has a small shearing strength against flowing, which can be measured by standard procedure. In this program, we shall demonstrate the determination of liquid limit of a given soil. The apparatus required for conducting this practical include mechanical liquid limit device, grooving tools like Casa Grande type and ASTM type tool, porcelain evaporating dish, spatula, balance with sensitivity to decimal 0.1 gram, thermostatically controlled oven, vase bottle containing distilled water, sample containers and 425 micron IS sieve. To start with the experiment, first inspect the liquid limit device to ensure that it is clean, dry and in working order. From the prepared soil sample passing 425 micron IS sieve, take about 120 gram sample in an evaporating dish. Add distilled water to the soil sample. Mix it thoroughly to form a uniform paste with the help of a spatula. If the soil is clayey, leave it to stand for 24 hours to ensure uniform moisture distribution. Now, place a portion of the paste in the cup of liquid limit device. Squeeze down and spread the paste in the cup with the spatula. Trim the soil at the top so that the maximum depth of soil in the cup is 1 centimeter. Transfer the excess soil to the dish. As the soil is clayey, use Casa Grande's grooving tool to divide the soil paste in the cup into two halves in a direction perpendicular to the axis of rotation of handle. If the soil is sandy, use ASTM type grooving tool. Now, lift and drop the cup by rotating the handle at the rate of 2 revolutions per second till two halves of the soil cake come in contact by flowing and not by sliding with the bottom of the groove along a distance of about 12 millimeter. Count the number of blows required and record the reading in the proforma. Ensure that the number of blows range between 15 to 35. From the flowed portion, take a representative sample using a spatula in a sample container of known weight. Ensure that the spatula cuts the soil cake at right angle to the groove as seen here. Determine the moisture content of this sample as per standard procedure. Record the container number, weight of container, weight of container plus wet soil, weight of container plus oven dry soil, weight of water, that is difference of W1 and W2, weight of oven dry soil, that is difference of W2 and W0, water content equal to weight of water divided by weight of oven dry soil into 100, so in this case the water content corresponding to 17 blows comes out to be 35.38%. Now repeat the procedure with different water contents, that is from drier to wetter condition of soil, and record the various observations 3 to 4 times. Now to analyze and interpret the results for liquid limit test, we plot a graph between number of blows and water content on a semi-log graph, making use of readings recorded during various tests. The moisture content corresponding to 25 blows from the flow curve, that is 31.50, is the liquid limit of the soil. Now we shall perform the test for plastic limit of soil. Plastic limit of a soil is the water content at which a soil just begins to crumble when rolled into a thread approximately 3 mm in diameter. The apparatus required for conducting this practical include porcelain evaporating dish, ground glass plate, metallic rod of 3 mm diameter, spatula, sample containers, thermostatically controlled oven, and 425 micron ISC. To begin with, take about 50 grams of soil sample passing 425 micron ISC from the prepared sample in the evaporating dish. Now add distilled water to the soil sample and mix it thoroughly so that the soil mass is plastic enough to be easily molded. Prepare a ball weighing about 8 grams out of this soil mass. Place the ball on the glass plate and roll it with the fingers so that a thread of uniform diameter is formed. The rate of rolling should be between 80 to 90 strokes per minute. Continue rolling till the thread reaches a diameter of 3 mm by taking reference of the metallic rod. Knead the soil of this thread into a ball and roll it again into a thread. Repeat the process of kneading and rolling until thread starts crumbling just before attaining a diameter of 3 mm. Now collect the pieces of crumbled soil thread in a container of known weight. Determine the moisture content as per standard procedure. Record the container number, weight of container, weight of container plus wet soil, weight of container plus oven dry soil, weight of water, that is difference of W1 and W2, weight of oven dry soil, that is difference of W2 and W0, content is equal to weight of water divided by weight of oven dry soil into 100. For this case, the water content is 21.37%. Repeat the procedure 2 more times and record the water content. The average of the determinations, that is 21.16%, is the plasticity limit of the soil. After determining the liquid limit and plastic limit of the soil, we shall now determine the plasticity index, which is the difference between liquid limit and plastic limit. IP equal to WL minus WP. Putting the values 31.5 minus 21.16. So, in this case plasticity index IP equal to 10.34. Finally, to classify the soil, we refer to the plasticity chart as per IS code 1498. In this case, the liquid limit is 31.5 and plasticity index is 10.34. Thus, the soil is of CL type, that is clay with low compressibility. Similarly, we can classify the soil of different values of liquid limit and plasticity index.